Hey, how's it going? So, today we're going to talk about cones and whatnot, so you'll be able to see. And if I change the camera, pardon me for a sec. If I change the camera, you may not have heard me. What you'll see is a cone. Here's the cone. Looks very cone-like, so forth and so on. A little blurred, but that's a cone. Round base, meets up at a point. And we're particularly going to be talking about today conic sections. And conic sections is the area of mathematics in which we slice a cone in a different ways, a variety of different ways, in order to produce a variety of geometric figures. Let's begin. So, there's a picture of the cone sliced in a variety of ways, and out of that we get a variety of different things. You've got that picture in your notes, but it's really, really, really tiny. I should probably get my little notepad card thing out. Hope it starts because it's not been plugged in. But conic sections, as you can see, we've got some various different things depending on how we slice it. We're going to talk about how we slice it, how it impacts what we do. So, if we slice and we slice so that our plane intersects the cone parallel to the base. Our plane intersects the cone parallel to the base. What do you think we get? I'll show you. The cutaway part is a circle. Is it a circle? It's like a circle. Okay, if I tip it a little bit, okay, we just chopped the top of the cone off. Used to have a cone, used to have a top, now it has not. Okay, so we get ourselves a circle. And the circle has the equation x minus h plus y minus k, x minus h squared plus y minus k squared equals r squared. And in that particular equation, h comma k, that tells me where the center of my circle is, and r is my radius. Okay? If my center is at the circle, then we just use this, x squared plus y squared is equal to r squared, which is a lot like the Pythagorean theorem. This is all built off the Pythagorean theorem. As you're working on your projects with conic sections, you're going to need to be able to play around and put this into a y equals form in your calculator. So we'll walk through how to do that on this one, and we kind of leave that up to you as we move forward. So if I take this x minus h squared plus y minus k squared equals r squared, to solve it for y, I'm going to first get rid of that x minus h squared. And so I'm going to have r squared minus x minus h squared. And then I'm going to take the square root of the whole thing. So I'm going to have y minus k equals plus or minus the square root of r squared minus parentheses x minus h squared. And then y is going to equal k plus or minus the square root of r squared minus x minus h squared. So when you put this into your calculator, if you just put in the k plus part, then you're just going to get that part of the circle. It's not really a great circle, but you get the idea. And so what you're going to have to do is put two equations in. You're going to have to do the plus and the minus, and then you'll get the other half of the circle. And person. All right, so anyway, that's a circle. What if we slice the cone differently? What if we slice the cone on an angle? What if the plane intersects the cone at an angle? If that happens, what we end up getting is can't really tell that it is that. You get an ellipse. You get that shape. So, it's kind of an elongated circle. The other way I can try to get it. I have another little handy device. I can get it to fix in. Let it go there. It's going to be well worth the wait, I swear. I promise. I need another hand to get this to work. Okay. After all that, it fell. Let's get the ellipse shape by cutting it in there. Okay. Just hold it with my hands. The ellipse. It's just some spectacular work right there. Let's go back to the wooden one. Forget that. Back to the wooden one. We get the ellipse. You can't really tell because we're not on the angle, but it's there. You know what an ellipse looks like. Need to get that thing back. Every time is slipping away. This video could turn out to be a long time. But anyway, ellipse. Boom. So the equation for ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. And so what this tells me, h and k are still my center, and a and b give me the indication, so kind of a will give me my x-intercepts, and b gives me my y-intercepts. So, you know, if I want the x-axis, I want the ellipse to kind of look, I don't know, let's see if I can draw an ellipse. If I want an ellipse that looks sort of like that, then I want my a values to be smaller than my b values. So, you know, I might say this is 3 squared and that's 5 squared, and I'd get intercepts up here plus minus 5, back there plus minus 3. If I want an ellipse that looks, well, that way, then I'd want my a values to be larger than my b values, okay? Depending on just which way you want it to be oriented. Again, if we're centered at the circle, then you're just going to have ax squared plus by squared equals r squared. We can quickly turn that into this form if we just divide everything through, in this case by 144, because this is by 1. So if I divide by 144, I divide by 144, and I divide by 144, this actually becomes x squared over 16, because 9 times 16 is 144. Clever, huh? And then this becomes y squared over 9, same reason, equals 1. So if I drew this, I'd get an ellipse that was centered at the origin. It crosses the x-axis out here at 4, crosses the y-axis at 3, and maybe, just maybe, looks like something like that. So again, with this one, you're going to have to, in order to use the graphing calculators to be able to put this in, you're going to have to solve this for y. Okay, so, you know, you're probably first going to want to add this to both sides, and then, or subtract that from both sides, and then multiply through by b squared, then take the square root, and then do k, and you're going to have to do 2 equations to make it work out. Okay, so the ellipse. Next, if I slice through the cone, okay, and I actually intersect the base of the cone, if I actually go through the base of the cone, what I get, all set up, is a different shape that you're probably familiar with. You probably can see it even there on the red. We're going to go with that version, see if it works out. Is that. What's it look like? Hopefully you're thinking a parabola. Okay, it does. It looks just like a parabola. I can show you with the thing there, but you can't really see it because it's going to be sideways. But you get a parabola. See, if you notice that it cuts into the base, cuts the base apart, and it's not parallel, it just kind of kits it at an angle. We get a parabola. Equation for a parabola, you might remember, that's the one we'll be using. Y minus k equals a times x minus h, and in this case h and k talk about the vertex, and a is about the shape of the parabola. Okay, so whether it opens upward or downward, whether it's a narrow parabola or a big or wide parabola, A takes control of that part. And again, you know, solving this one for y is pretty darn easy. Add k to both sides and you're in, okay? And you just get the parabola that way, okay? All right, so parabolas, what's left? Oh, this is the crazy one. We take 2 cones, we stack them up on top of each other. We slice through the planes. We slice through the plane that is parallel to the main axis. So the main axis would be the one that starts up here, goes through both vertexes, and just sits right down the center. So from the center of the circle through the vertices to the other center of the circle. When we slice that, we get shape, and I'm just going to forego the whole stacking things. We get what's called a hyperbola. Okay, so you've seen hyperbolas before, and you know, without me stacking, or I'm going to do it because I said I would. Get to there. Watch. There's one. There's the other. Stack them up. Hopefully they balance. And you get. See it? See the shapes? 2 things right together. Hyperbola. All right, that was really, really not worth the effort. Conic sections. All right, so again, with these hyperbolas, so they can go either way. They can either have the axis this way, so if we have this sort of an equation, the hyperbola might open this way, and this hyperbola probably opens that way. Okay, A and B give some indication. A and B actually control like the steepness of the hyperbola. They talk about the slope of the asymptotes, the slant asymptotes. So, and that the slope of these is B over A, plus and minus. So, depending on what how wide you want it to open, if you have a larger ratio of B to A, you get a more narrow hyperbola. If it's smaller the other way, then we get a wider one because the slope of that line changes. Let's see, what else do we want to tell you? H and K gives an indication of where the center is, so you can move them up and down and left and right if you need to, and you'll just kind of have to play with the hyperbola. You might see an equation in this form, ax squared minus by squared equals r squared. Again, same thing to make it into that format. We divide by 36. We would divide by 36. We would divide by 36. That's going to make this equation x squared over 4 minus y squared over 9 equals 1. Okay? And so in this case, my a value would be 2, and my b value would be 3. Okay? If I go through that, I've got a little hyperbola maker on the next page. So if I make my a value equal to, what did I say, 2? That's going to annoy me. My a value is 2. Can I do this? Come on now. Should let me change that to 2. My y value is 3. Okay, and then I'll make these both 0. Let's make that add. I see how it all works. Okay. Do it. Alright, so there's those. So that's the hyperbola that we pictured. If I draw in those asymptotes, you see that they have a slope of 3/2, right? So we go up 1, up 3 and over 2 is kind of what's going on here. Up 6 and over 4. So that's the slope if it's based on these numbers. And I can show you that it comes from the right triangle. There's the slope, the rise over the run, and if I want to move them left or right, I can do that with just adding and subtracting. I can move them up and down with adding and subtracting numbers, that sort of thing. Okay? Notice the equation changes. Okay? X squared over 2 squared, y squared. Okay? So that makes the hyperbola. If it's the other way, then the hyperbola is just going to open the other end. Okay? Instead of having side by sides an hourglass figure, we'll have like a sideways hourglass, we'll call it. Okay, conic sections. The other conic section that we'll worry about is a line, and a line basically is what happens if the plane is tangent to the edge of the cone, so that the plane that we're intersecting just touches the cone. Then we get the intersection as a line. Y equals mx plus b. We know about it. Not going to dwell on it. So, what have we learned? We've learned about the circle. We've learned about the ellipse. We've learned about the parabola, and we've learned about the hyperbola. Okay. And how to make them by slicing into cones. Slicing parallel, slicing at an angle, slicing at an angle through the base, slicing parallel to the main axis gets us the old hyperbola. Okay? And you'll play with those as you go through. So there's that. Oops, I didn't want that. I don't know what's going on. I wanted to get to there. The end. And that is, indeed, my friends, the end. Did I show you that? I did show you that. And I will show you that again. Thanks for watching. You learned something? Talk to you tomorrow. That is excellent. 13 minutes, just under 14 on this video. I'm going to stop it at exactly 14. Excited.